I'm Chris Knight. I'm from the AIM Research Center.
That's fine. Go
Sorry.
ahead. Chris Knight from AIM Research Center, and he's doing Software Bus Network. I'm going to make sure I get the right topic down.
Yeah. I'll be fairly quick, and I really want this to be more interactive because there's been a lot of recent, like in the last month, interest and activity on SBN, and as I've gone through, and I've started on CFS and SBN about a year and a half ago, and just spent like the last year kind of learning SBN, CFS, and then tuning the code, making it meet our needs in the iPaaS in our environment, and then seeing where the community is going. And I'm now a member of the CCB. I'm actually AIM's civil servant rep on the CCB. But this is just kind of a technical slide deck, and actually that's right, I got this little note for it. Hooray. SBN connects multiple CFS software buses together at a high level, and it's a modular architecture in the current implementation. Really, there's only two protocols that currently supports this, TCP and UDP. There are old versions of Serial and SpaceWire modules for it, but I think actually there's myself and maybe Beth will kind of start working. We'll work in collaboration on where this is going, but we'll start looking at integrating in the CITO modular architecture, and then also again looking at kind of the PSP and seeing if there's some common architecture decisions we can make where we can share, especially when we get in real time. There's going to be some really interesting challenges there. Beyond the modular architecture, also SBN has a heartbeat and announce protocol that allows you to be aware of when you're connected to peers on the network. And then I've added, one of the capabilities I added was the ability to remap and filter out messages between nodes in an SBN network, because the previous implementation, SBN, every message got sent to every other peer that was subscribed to it, except for events. But all commands and telemetry were if you had a subscriber on node A and node B had a publisher, every message would go across, even if you didn't necessarily want it. This gets into, again, kind of more the nuts and bolts of how SBN works. It talks through pipes to the software bus using some special telemetry and command types. The current implementation pulls, it pulls the pipes every scheduler tick, and as well it pulls every network connection, either serial device or socket, and we'll get into some issues with that. Also, SBN uses it ensures that all of the SBN protocol messages are big endian, as well as CCSDS headers over the wire, because we had some interesting issues when we had one node that was a big endian PowerPC and another was an Intel Linux box, and endian problems arose. So here's some kind of the high level, some of the issues that I've encountered and some of the possible solutions that I don't know if I want to get into these, but all this slide deck is in Babelfish, so for those who have access to that, and I'll write my email up on the board, or people can email the community list and I can get you a copy of the slide deck. But there's some scalability issues. There's the number of message IDs that CFS software bus limits you to currently, and we're evaluating if you increase that number, how does that scale? It's a very rudimentary network topology. There's very rudimentary, there's no, in the current implementation that I've been working on, there's no guarantee of delivery architecture. We're kind of pushing it down to TCP or your network layer, but there may be some advantage to having that at the SBN layer, and I'm going to trip myself. And again, the polling, I actually have a task-based implementation that will set up a task per peer connection, but then I think that's going to cause issues with real time, so I may not use that. as we go towards real time. And then the other thing is it's SBN, you configure it with flat text files as to where your peers are. And so if you want to change that network topology, you basically restart SBN to do that. So we're going to look at adding a capability to command it. And I think that CITO may have already addressed some of that, so we may adopt the same command model.
Yeah, we have a set of commands already defined and everything.
Yeah. That'd be great, yeah, so we'll look at that. So again, kind of the topology model, you can have multiple networks. Basically every network, generally speaking, every peer is talking to every other peer point to point. The different networks can be different protocol types, so you could have network number 0 could be a serial connection, net number 1 could be UDP, but generally they're the same network type within the network. That's just kind of, this is getting into more of the protocols. So one of the real difference between CITO and SBN is SBN, because it's bridging these buses, it's bridging all of the subscriptions that all of the applications are making between those buses. And so as peers connect, it does some peer handshaking where it shares what all the subscriptions are for so Node A says to Node B, hey, I've got a bunch of apps that have subscribed to these message IDs, and Node B says, I've got a bunch of apps that subscribe to those message IDs. And then they start sending the actual messages back and forth once they have that handshake. So again, let's kind of skip over some of this, some of the teardown. There's a heart beating model where the current implementation, if it doesn't see any traffic from its peer for a certain period of time, it says, oh, maybe the peer's gone, I'm going to, so then it disconnects the connection. Well, if I'm not sending to my peer for 10 seconds, I'm going to send a heartbeat just to make sure he doesn't drop me. Straightforward. Getting into here's the module data. So when you start up SBN, you specify a set of modules. These are the back end, the protocol modules. So in this case, UDP, TCP, and serial. And they're basically shared libraries, and you specify, it's very similar to your startup script. You specify your symbol that actually it's a list of callbacks that your module supports. Some configuration parameters in that, and then there's the compile time configuration parameters. And again, I won't go into these. Not terribly interesting. But there's basically two. There's the module file and there's the peer data file, which actually I've skipped over that. I'm sorry. There's the peer data file. So the peer data file just basically says, here's my network, and here's one row per peer. So I don't have any examples in here, but I might. No, I don't. And it basically just says where, like an IP address or a serial device file path, what have you. And so you have it, in this case, I have a network number, so you number each of your networks where you have all of your peers in the same network. Skip over that. There are a couple basic commands. You can do, basically it's all housekeeping and current status commands currently. Then getting into the what you can query. And the network protocol is actually very simple. In fact, so one of the things that we're looking at is developing JSC is looking at developing an SBN library. And so one model is that could just be someone else's code that talks the same protocol. And so the protocol is just a simple, it just sends the software bus messages with a small header, which SBN adds on top. Just specifying the size of the message, the type, whether it's a regular application CCSDS message or something having to do with SBN protocol, and then CPU ID of the sender. Let's see. This is for developing the back end for the UDP, TCP, serial, spacewire, TTE, all those networks. This is the entirety of the list of the methods they have to provide as part of their shared library to interface with SBN. This will probably grow because some of the protocol specifics of handshaking and announcing and network configuration may be pushed down into this layer, so this could be separated out, and this may actually become a separate library that then, if you don't want to have a full CFS environment, but you wanted to talk to an SPN network as if you were on their bus, this may be the way to do it. So, and that's all I have. So, so I don't know how many people here are interested in SPN, but I don't know if there's any questions and interest in adoption or directions you suggest.
I was wondering what's that on your shirt.
It's a band. It's a musical band called Vector. You can't really read it because technical metal. Yeah, that's why I wore it. I'm a nerd. So.
Yeah, the last thing you said about the another non-CFE client talking to over SPN, I think it'd be pretty neat for a small instrument, but node something the size, like Arduino sized or something that would be able to communicate with an SPN system.
Yeah.
And the idea originally that the SPN is simple enough, you could actually put it into an FPGA to have a piece of hardware join the bus, as always a full CFS application.
Yeah. The protocol is very simple.
Very simple.
Very simple. And I've written test code that just injected packets into the SPN and faked it. A little Python. I may have the code somewhere still. Of course, it needs to be updated. But and on the flip side of it, one of the other use cases, the SPN library model that we were talking about last week was displays. So you want to have a display come up, and you want a user to say, I want to watch this telemetry stream, or I don't. And so it wants to say, send me these packets or don't, or I want to join this network or disconnect from this network. But it doesn't need the whole CFS bus to do that. And so it may pretend to be a CFS node or SPN node to do that. So we'll see. But yeah, there's probably going to be quite a bit more development in the next year. But it's because of course, I came to this a little over a year ago, and SPN's been around for a couple of years. My understanding, though, is basically SPN is already in line to be open source, but I've asked around and said, hey, is there any reason why it shouldn't be? But my understanding is it's open source.
Just to give some background, SPN has always been prototype because we didn't have a mission that wanted to go through the Class B process. So if you find issues with it, it's because it was written as prototype code.
Yeah, there were certainly issues with it when I got it, where it wouldn't. If you had 3 nodes connected together at the same time, it wouldn't work. It would lock up, and that was one example of an issue that worked great one to one, but 3-way, nope.
Anything else?
Yeah, so it is on SourceForge, the prototype version, but it is, like we said, a prototype. You're not going to find, doesn't have requirements. There's minimal design documentation. There's no user guide, and
it's,
I've we're looking
minimally
forward
updated
to
the documentation. The one thing I'm really nervous and shaking my boots about is developing a UT Assert test suite for this is going to be challenging, because you have to really do it right to simulate multiple node networks and multiple network types, and it's going to be a challenge.
Well, actually, for the UTSR unit testing, you probably don't have to go into that level of detail because you usually want to abstract the way the
Well, stubbing out all the
Because that's more of a functional test that you're describing, right?
well, even just because I have to think about it. I've not really.
Okay. Well, I'm guessing based on having unit tests and a whole bunch of applications that most of those details would go away as you just test the higher level function that contains the lower level stuff.
Yeah.
Right.
And so now we need somebody to write a Wireshark protocol analyzer for it.
That's certainly possible. Actually, the Python code that I wrote was it would not only connect to an SPN network, but it would you could actually use it as a filter and connect two SBN networks together. So in that case, you could even examine the packets as they went through. And that's actually one of my slides also talked about, there's no routing per se. And so that's something that with really complex spacecraft, if we're looking at habitats and stuff, you're going to have very complex networks of networks, and how that works, and doing relaying between networks is that can, you can become a Cisco. And
Yeah, that was actually on the to-do list about 8 years ago.
Yeah, but it's
So-
I'm not tackling it for a while because it's a really hard problem in the long run. It seems simple, then you keep adding on and getting worse and worse. You had a question back there. So.
Yeah, just a quick suggestion. Right now, you're kind of focused on the space packet protocol layer, which is pretty much all the software bus talks. It might be interesting if you take this up a level and talk telecommands or TCs. That essentially would give you all the multiplexing that you would need, as well as include your spacecraft ID. So just a thought. It's a different CCSDS protocol.
Yeah, I'm
which
not
is
sure
one layer above
if I could even
ramps.
get at that layer. I mean,
Yeah, I think we're probably good with the extended header. We get the stuff we need, and not
Yeah.
necessarily the TC. So we can send commands just as easily as any telemetry packet over SPN and software.
that's true. That
Yeah.
the APID expansion will alleviate that
Yes, alleviate
and
some
cause
of that.
other problems.
Actually, it makes SPN a little easier because you don't have to have as much metadata.
Hmm.
You don't have to wrap the packet as much because it's already got everything you need
Yep.
to do the routing.
Yep. More questions?
You said you wrote it in Python, and is Python?
No. So SBN is a application written in C. At one point, this is 9 months ago when I first started working with SBN, I wrote a Python standalone program that would mimic would talk the SBN protocol, and so I could from Python talk to SBN. But I don't even know where that code is, let alone I know it's out of date. So. But it wouldn't be hard to recreate that code. It wasn't that. Again, the protocol is very simple.
All right, thanks, Chris.
Thank you.